So in number 37, you've got two objects with mass of 200 kilograms and 500 kilograms that are separated by 0.4 meters. A, find the net gravitational force exerted by these objects on a 50 kilogram object placed midway between them. So in this case, we'd have the 50 kilogram object 0.2 meters from one and 0.2 meters from the other. The attraction for the 200 kilogram object, just using the universal law of gravitation, we can just plug and chug, plugging in one mass of 200, the other one 50, the distance between them 0.2, you'll discover that that force is approximately that many newtons. Fairly small, but okay. And then we'll do the same thing for the other side to find that force. Now this one's going to be larger because we have a larger mass, but just plugging in our numbers, 550 this time, same distance between them, you'll discover the force is that. So what's the net force? Well, just the difference between these two, which ends up being about 0.000025 newtons towards the right, which I'll leave as positive. For part B, the question is, where should you place this so the two forces are equal? Well, logically, you would want to put it closer to the 200 kilogram and further from the 500. So even though the 500 has a larger mass, the greater distance would offset it. So what do we have here? I'm going to call this distance x. And in that case, then, this distance over on this side is going to be 0.4 meters minus x. What do we know has to be true about these two forces? These two forces of gravity must be exactly equal and opposite magnitude. To write that, I'm just going to go ahead and write this equation. The gravitational force on one side, 200 times 50 over x squared, equals the gravitational force on the other side, 500 times 50 over 0.4 minus x squared. Now I'm going to do a bunch of cancellations. G's cancel, the 50 cancels, and I'm going to cancel out 100 from both sides. And then from that point forward, probably just cross multiplying. That'll give me the 5 here times the x squared over here, gives us 5x squared on this side. And then on the other side, the 2 here times this portion here gives me the other side of this expression right here. From here, we just got to do some algebra, don't worry. Squaring that other side, or doing the FOIL, multiplying it by 2 gives me that. And the 5x squared stays there. Subtracting 5x squared from both sides gives me this. Again, solving the quadratic, you'll get two solutions. And the solution we want is this one. The negative one, yeah, it technically is correct. At that point, the two forces are equal. But we're talking about a point that's somewhere over in this region right here. And at this point, you're closer to the 200, but further to the 500. But in this case, the two forces are equal, but actually acting in the same direction. So technically, it fits the equation, but doesn't solve the problem of a net force is 0. Hope that helps.